Yay. All right, everybody has a worksheet in front of them. Very good. All right, today we're talking about building linear models given a word problem, a real world situation. So the very first thing that you should do, and this is the step that almost every student in Math 1 through Math 3 skips, is you need to identify the variables of interest. What two quantities is the problem working with? What are we comparing? And you need to label them in words. Give them a name and define them. If it's cost, you should write C equals cost. Yeah. Population, P equals population. Give them names that make sense. Write them down so other people looking at your equation know what the letters in them mean. Yeah. Good. Second step is you pick off all the numbers they gave you. And generally, when we're talking about linear word problems, you're going to see one of two flavors. The first is the nice one. They're going to give you the slope and the intercept. And if they do that, you just move on to the next step. Write them down, move on. The other flavor is they're going to give you two ordered pairs, two input-output pairs. They may not be written as coordinates. It might say in 1995 the student population was 400, and in 2000 the student population was 800. That's two pairs of numbers, a year and a population, a year and a population. So if you see two pairs of numbers, they've given you 2 points on the line. You need to calculate the slope and the y-intercept, which we just practiced. Yay, we have those skills. Once we got our slope and our y-intercept, we can write the equation that models the problem. The third step is just write the equation in slope-intercept form. Plug in the M, plug in the B. Some questions will stop there. They just ask you for the equation. Some will ask you to write the equation and then ask you to do stuff with it. And those usually come in two flavors. First, they're going to give you an x value, meaning you know what x is, and they want you to predict the y value that goes with it. You're going to make a prediction. Take the x value, shove it into the equation you just wrote, calculate the y value that comes out. Sometimes the other type of question is they're going to give you a y value and ask you to work backwards, meaning you know what the answer is. They want you to identify the input that makes it true. You have to solve the equation for x. And at the end of this process, you should have an answer. You should write that answer in sentence form, preferably of the complete variety. Context to your numbers. You solve the word problem, you get an answer of 25. What is that? 25 oranges, $25, 25 years. Tell me what it is you just found. Yeah? 5 steps. Identify, yeah, numbers, write your equation, solve sentence. 5 steps. We're going to apply those to a couple of word problems. So let's do the first one together. First one says a company sells donuts. They incur a fixed cost of $25,000 for rent, insurance, and other expenses. It costs 25 cents to produce each donut. Write a linear model to represent the cost C of the company as a function of X, the number of donuts produced. Find and interpret the y-intercept. So, write a linear model. That means write an equation. We want an equation that models the cost of a donut. Step one, identify the variables we are interested in. So that's the second sentence. I think it's the second sentence. No, it's A. What does A say? What two variables are mentioned in A? Ooh. They labeled them for us. Cecilia, what's one of those variables in that word problem A? C. Yeah, they give us C and they tell us what C is. They say C is equal to the cost. Yeah. As a function of, and it says X. What does X stand for? Ooh, Alan, what does X stand for? Number of donuts, yeah. C is a cost as a function of X. X is the number of donuts. So I want to know what the cost is if I make 5 donuts, if I make 10 donuts, if I make 1,000 donuts. Cost in terms of number of donuts. Which one of those variables does it make more sense for it to be the input? Number of donuts or cost? Which one is the input? Number, yeah. Yeah, this is our input. And cost is our, if I could spell today, is our output. Yeah. I choose the number of donuts, I shove that number into the equation tells me the cost that goes with it. Input is number of donuts, output is cost. Yeah, good. Step 2, we go through the equation. We pick off our numbers. I spy 2 of them. I see fixed cost of 25,000. I see 25 cents to produce each donut. The question is, what did they just give me? We have 2 choices, slope and intercept or 2 ordered pairs. So did they give me slope and intercept or 2 ordered pairs? Slope and intercept. I only see 2 values. If it was ordered pairs, I would need 4. Yeah. So the question is, which one of those is my slope? Which one is my intercept? So we have to think about what those are. Earlier this week, you guys told me when we graph a line that my y-intercept is the point where the graph crosses the line. Yeah? What is the x value at the y-intercept? 0. Yeah. It's the y value when x equals 0. In this problem, that means it is the cost for the donut company when it doesn't make any donuts. So how much does this company spend before it even rolls 1 donut off the line? $25,000. That's how much the rent and the insurance and all of that other fun back end stuff is. Yeah. So my y-intercept B is my initial value. I don't like spelling that word. Too many letters in that word. So our y-intercept is the initial value when we haven't made any donuts, and the problem told us 25,000. That's nice, because now we know what the other value is. The other value must be our slope. And our slope was 25 cents per donut. So 25,000 just to turn the lights on in the factory, and then I'm going to pay a quarter every time I roll a donut off the factory line. Yeah. You will notice in word problems that are linear, the slope will almost always have this word in its definition. Because slope is change in y over change in x. It's a division problem. And division problems are top per bottom, y per x, dollars per donut. So if you see something per something, that's probably your slope. Yeah? We didn't see that here. We did see cost to produce each, which is 25 cents for one donut. They're giving it to you in slightly different wording, but the concept is the same. Most word problems will use that. That is more common. Okay, now the tricky part. Now that I have the numbers, what does my equation look like? Ooh. What is my output variable? What is my output variable? C. Yeah, my output variable is C. And slope-intercept form, y equals mx plus b, that's output equals slope times input plus intercept. Yeah. Output equals slope times input variable, which is x plus y-intercept. So way back at the beginning when we labeled our variables, it's important that we identify which one is input and which one is output so that we know where to put those letters in the slope-intercept form equation. Output should be on the left by itself. Input is next to the slope. Fun times. Okay. Questions on what we just did? Yes. That's a really good question. So here in this problem, they asked us two things. First was write a linear model. So this was our answer to A. That was our linear model. And then B said find and interpret the y-intercept. So this right here was our B. And you had to do B first because you needed the intercept for your answer to A. So we did both. They didn't ask us to make a prediction. The next one will. That was a good question. Other questions? Thoughts? Concerns? Are we awake after lunch today? No, if I can't nap, you can't nap. Okay, we're going to try another one. It'd be nice if somebody other than me would read it. Can somebody please read out that second example? Very good. Thank you, Rado. So word problem, 2 directions for the word problem. We're going to start the same way. We're going to pick through that information and identify the 2 quantities that we are interested in. And they gave us a bunch of numbers. How many numbers did they give us before we got to A and B, ignoring A and B, just in the base word problem? How many numbers did they give us? 4. I have a sneaking suspicion they gave me 2 ordered pairs. So I'm going to look at the structure of those ordered pairs. That first pair of numbers, 2008 population was 28,200. They gave me a year and they gave me a population, meaning those are the 2 things I'm interested in. So my 2 variables are year and population. And we're going to choose letters to represent our variables. We're going to name them. We can name them whatever we want. I had a student when I taught math 1 in Stockton who did X as happy face and Y as frowny face for the entire school year, and that's fine. But we should name them. Suggestions for what we want to name year. Y. Popular, logical. What about population? P. Again, logical, neat, tidy. We like that. We have to sort out what the input is and what the output is. So do I know the population and then look back what the year is, or do I know the year and then look up the population? Know the year, look up the population. So the year is the input. That's the thing that I know. The population is the output. That's the thing I look up. Yeah. Scoochie this way. I'm getting a little tight there. There we go. So when I write my equation, it's going to be P equals my plus b. Output equals slope times input plus intercept. And it's going to feel awkward. That's the right way to do it. Yeah? Okay, let's write our ordered pairs down. I have 1 underlined in red. I've got 1 underlined in blue. So I've got 2008, 28,200, and 2023, 36,800. Step 1, step 2 are done. I identify my variables. I wrote down my numbers. Step 3. What should I do at step 3? I'm writing a linear equation. What do I do now? We just did it for the warm-up. Yeah, so slope equation. Yeah, perfect. Let's find the slope. So m equals y2 is 36800. Y1 is 28200. X2 is 2023. X1 is 2008. And we're going to do this on a calculator, and it's going to give us an ugly decimal, and that is okay. 36,800, 28,200, 2023, 2008. And I get 573.3. 33, 33, 33, 33 forever and ever. Hopefully somebody else has a calculator out and is checking my math. I have been known to make boo-boos at this time of day. Perfect. I got my slope. What do I find next? Alex, what do I find next? Should be in that step list at the top of the page. Find the slope, find the y-intercept. Perfect. Gold star. Find the y-intercept. So we're going to write our equation, plug a point in, just like we did for the bell ringer today. So my equation is my population is equal to my slope times my input plus b. Input equals slope times output equals slope times input plus b. We're going to pick a point. Doesn't matter which point. If both are positive, pick the one with smaller numbers. I'm going to use the 2008 value. So at 2008, my population is 28,200, 573.3. My year is 2008 plus B. Substituting that first ordered pair, population and year, into the equation. I'm going to do that multiplication. I'm going to get a big answer, and that's okay. So 28,200 equals, oh, that is yuck, 1,151,186.4. Not pretty, but it's correct. That's what my calculator said. I want to solve for B. How do I undo that addition? Subtract. We're going to subtract that from both sides. Yeah. Yeah. And we're going to get something negative. So 28,200 minus 1,151,186.4. And I get negative 1122,986.4. And we're going to think, as mathematicians, we want to make sure that answer makes sense in terms of what we know about our system. So remember that our y-intercept is the value when x is 0, when our input is 0. So this is the population of the town in year 0. Ooh, our population in 2008 is about 28,000. And we're changing by a little bit under 600 a year. So if I start in 2008 and I start counting back towards year 0 and I subtract 600 every year, does it make sense after 2008 years that I end up here? Yeah, yeah, because that's 2008 times that I'm subtracting just under 1,000 people. Yeah, it's going to get low really quick. So that does make sense in terms of what we're doing, because the numbers we're looking at are really far from 0. We're all the way out in 2008, 2020. That's really far from 0. If we go backwards, that's fine. So our equation is just P equals 573.3y minus 1,122,986.4. Happy face. Happy face. And I see people making frowny faces. Hopefully that's you realizing that you can't actually have a negative population. So the population growth hasn't been linear the whole time the population existed. At some point there was no town, and then one person came and two people came. It probably grew very steeply and then started turning linear. Yeah. Okay. Now we're going back to the question Julie asked at the end of the last question, which is, aren't we going to do something with that? And the answer is yes. They ask us to make a prediction. What is the population in the year 2014? Question A, what is the population in the year 2014? The question is, how do I do that? Wait. Can you start that at the beginning? I wouldn't do 9 times because you're thinking change in. We want to do the whole year times. So it would be the 573.3 times and then our year 2014 minus. Right? Because that's what Y stands for. It stands for year. If I know the year is 2014, let's stick it in for Y. We can solve for the P that goes with it. So 573.3 times 2014 minus 1122986.4. And I'm going to round that up to the nearest whole number because I shouldn't have a fraction of a person. That would be gross. And I get 31,640 if I round up. This 39.8, but I shouldn't have 0.8 of a person. My question to the class is, does that make sense in terms of the information we were given in the problem? And I see some people nodding their head yes lately. And I agree, I'm going to zoom out. If I go back to those points, 2008, we had 28,000. 2023, we had about 37,000. 2014 is between them. 31,000 is between them. So the X is between the 2 years we had. The Y is between the 2 populations we had. That works out well. That checks out. Good. Yay. Okay. Now for B, we did A. What does B ask us to do? Very good. What year will result in a population of 54,000? They're giving us P. They want a Y that goes with it. Same process. But now I'm not plugging in for Y, I'm plugging in for P. Yeah. 54,000 equals 573.3 times Y minus 1122986.4. And that's a two-step algebra question. I want to get Y by itself. I remember when I'm solving equations, I do reverse PEMDAS. Start at the bottom with the addition and your subtraction, work your way up. What do I undo first? Yeah, got to undo that subtraction by adding this to both sides. So 54,000 plus 1122986.4. And we get 1176986.4 equals 573.3 Y. Yay. Halfway there. Operation between the number and the Y is multiplication. How do I undo that? Division. We're going to divide whoops, by that slope. So I want my answer divided by 573.3, and I get an error because I can't type. Try that again. I get 2053. I did it. Somebody check. I see Chromebooks open. I see cell phones. Somebody should check. Did Mr. J make a boo-boo? Intuitively, to me, it makes sense because we know in 2023 we were at 36 something. 54 is bigger than that, so I've got to be out past 23. And you guys will start approaching my age, and I'll be a crotchety old man at 53. Yeah. Good. Okay. Questions on the front side? Question? No. Okay. The back side talks a little bit about drawing pictures. We're not going to do the problem today because my other class didn't get to it, but I would like to remind you that some problems will make sense after you draw a picture. It is a common tool for anything that involves things that relate like area, distance, time, speed. Those things happen on the surface of the earth. We can draw them out. They are most common with distance and speed problems. Those are situations where we would want to draw a picture of the motion of the object or how far it traveled to make sense of what it looks like in space. Yeah. We're going to tackle the word problem on block day. That's how we'll kick off our block period before we do our team task. On Friday, please bring your Chromebook and make sure that you have your social security number, if you have one, somewhere on you. You shouldn't bring the card with you, but like put the number in your notes on your phone, because we are going to Friday fill out some forms for Hartnell. Our representative from Hartnell is going to come to class and how to walk you through how to do that, and you're going to need some personal information. Yeah. If you need information that you don't have with you in class on Friday, you will be able to fill those forms out at home. I would strongly recommend you sit down with an adult and do that Friday evening. The longer students took to do it last year, the longer it took to get them Canvas access, the harder the course was for them. So fast is important, yeah? Okay, you've got a couple minutes to work on homework. If you have questions, let me know. Yes?
Sign up for other courses that I know while they're here. Can we ask them like that?
So once you're enrolled, yes, you can sign up for other classes at Hartnell. The difference is because this one is in a dual enrollment, Salinas Union High School District is paying your fees, buying your books, paying for that access. If you're taking a course that's outside of dual enrollment, all of those fees are on you. Yeah, which I mean isn't terribly expensive as far as I know. It's still pretty cheap. Where am I looking? Okay. So input, output. So yeah, that's good. All right. So negative 1, 4, 5 and 1. You did 1 minus 4, 5 minus a minus 1. That's perfect. You plugged in the negative 1/2. You added it to both sides. That looks great. Perfect. 11, 5, 4 and 1.
Oh, look at Julie being woman instead.
Yeah. Good. Yeah. 6 and 8. 4 and negative 2. Okay. Yeah, no, it looks like you got the process down. That looks good. Good, good, good. Okay, so this one, I will.
tell me what those problems that I'm having trouble on?
Mhm.
It's just like 3 of them. Right?
Yeah.
Okay, cool.
Yeah.
And then
1 minus 2, 0 minus 1. Yeah. Yeah. Okay. And then you did y x slope. Yeah.
you record your
Yeah.
classes?
That's good. I did. I should stop recording. I'm gonna have to go cut the tail off of this one. That's okay. So y2 minus y1, x2 minus x1. And then you picked this point for your substitution. That looks good.
Okay, cool. I just don't
Yeah.
want to do wrong and have written everything.
No, I get that. I totally get that. And I appreciate that you're on top of it. Yeah.